$70. One scrap propane tank from a junkyard. No lithium, no cobalt, no rare earth metals, no exotic parts, nothing you need a chemistry degree to understand. That tank stores your solar power overnight without a single battery cell inside it. Sit with that for 1 second. That's the whole video, right there. This isn't some garage theory I cooked up. This principle was proven in 1978 in a facility that is still running today. Right now, as you're watching this. 45 plus years, 0 battery cells, and it still works exactly like day one. Notice that year, 1978. Hold on to it, because it matters more than you think. Nobody banned this technology. Nobody made it illegal. There's no cover-up with men in suits burning documents. It's way simpler and honestly way more infuriating than that. It just stopped being profitable to sell you. And that's the part nobody in the storage industry wants you thinking about. Because the second you understand why it disappeared, you start asking why they've spent 30 years selling you the expensive version instead. By the end of this video, you'll know exactly what this thing is, exactly how the physics works, and exactly how to build one yourself for under $200. But first, you need to meet the guy who's been quietly getting rich off you not knowing this. If you've got solar panels on your roof, you already know the problem, even if you've never put words to it. The sun does its best work between 11 in the morning and 3 in the afternoon. But your house does its heaviest lifting between 6 and 9 at night. Cooking, laundry, lights, TV, everything running at once, right at the exact moment your panels have gone quiet for the day. So here's what actually happens to your money. During the day, you sell your extra solar power back to the grid for around 7 to 8 cents a kilowatt hour. Then that same evening, you buy that exact same electricity back at 30 to 35 cents a kilowatt hour. Read that again. You're selling low and buying high on your own electricity every single day, and most homeowners don't even realize it's happening. This isn't a technology problem. It's an economics problem, and somebody's making bank off it. Roughly 60% of an average household's electricity use happens in the evening and overnight hours. Which means even with a perfectly sized solar array, if you don't have storage, you're only ever using a fraction of the power you made yourself. You keep paying a power bill every single month for electricity you already generated on your own roof, and then just gave away for pennies. The official fix has a name: battery storage. And here's your villain, right on schedule. A lithium iron phosphate system for a single-family home runs somewhere between $6,000 and $16,000 installed. Lifespan is 10 to 15 years tops. After that, capacity drops to 70 or 80% of what it started at, conveniently right around the time they'd love for you to buy another one. Picture a 20-liter bucket. You fill it with water every morning. By evening, you go to empty it out, but some of it has quietly evaporated over the course of the day. And after 10 years of use, that bucket develops a crack, and it starts losing half of what you put in it. That's exactly what a chemical battery does. It ages. It leaks capacity. Eventually, it has to be replaced, and every single time, you pay again. Now picture a container that never ages, never cracks, never loses a single watt hour, whether you fill it 100 times or 100,000 times. What if that container has existed since 1978, and you can grab one at a scrapyard for $70? Before we get there, let's actually name the villain, because the industry talk is a cop-out, and you deserve better than that. The home battery storage market is exploding right now. Hundreds of thousands of new residential battery systems go in every single year, and that's a multi-billion-dollar industry with margins that would make your jaw drop. A 10 kilowatt-hour storage unit costs somewhere between $1,500 and $2,200 to actually manufacture. On your installer's quote, that exact same unit gets marked up to $8,500 to $13,000. That's not a typo. That's the game. Add maintenance. Add the replacement you'll need in a decade. Guaranteed, built into the design. Walk down the energy aisle at any big hardware store and count what you see. Solar panels, inverters, cabling, mounting rails, battery storage, more battery storage. What you will not find anywhere on that shelf, not one single sign of it, is any hint that another way to store energy even exists. One that needs no lithium, no inverter, and no guy in a van charging you $150 an hour to service it. The average homeowner drops somewhere between $9,000 and $16,000 just so their own solar power can survive until nighttime. That's the toll booth. And the industry built it, priced it, and put a 15-year expiration sticker on it, right on schedule. Nobody's straight up lying to you here. To be fair, the batteries genuinely work. But a fix that costs $70 and basically never dies? You will not find that in any catalog. Not because someone's hiding a folder marked top secret, because there's zero recurring cash in it for anyone. No subscription, no replacement cycle, no van, no invoice, no upsell. And that's exactly where this flips on its head. Stick around, because what you're about to learn is the part the industry would genuinely prefer you never connect the dots on. If you want more of this kind of forgotten, practical engineering, the stuff that still works today whether or not anyone's selling it to you, hit subscribe. It genuinely helps keep this channel going. Now, back to the tank. Right now you might be thinking, an old gas tank storing electricity? That sounds like a garage experiment, not a real system. Fair question. But every single propane cylinder that's ever been in circulation was manufactured to a certified pressure standard and independently tested before it was ever sold. These tanks are rated to withstand a minimum operating pressure of around 30 bar. What we're actually going to run through one is somewhere between 8 and 20 bar. That's a fraction, a small fraction, of what the tank is built to handle. From a safety engineering standpoint, this thing operates nowhere near its limit. This isn't a hack. This is real engineering, sitting quietly inside a steel shell that most people throw away. And the story of why this works doesn't start in a garage. It starts in 1857, high in the Alps, on the border between two kingdoms that don't even exist by those names anymore. An engineer named Germain Sommeler is standing in front of a problem that looks, on paper, unsolvable. He has to blast a tunnel straight through 8 miles of solid mountain rock. Steam engines don't work underground. The smoke would kill every worker inside the shaft before the job was half done. So Sommeler does something nobody had tried at that scale before. He uses mountain streams. Water power compresses ordinary air into iron tanks. That compressed air, not steam, not fire, drives the drilling machines deep inside the mountain. No flame, no smoke, no exhaust to poison the tunnel. The tunnel gets finished. And the principle behind it gets a name: compressed air energy storage. 30 years later, an entire city builds its infrastructure around that exact same idea. In 1888, a compressed air network goes live under the streets of Paris. Over 30 miles of compressed air piping running beneath the city, feeding workshops, clockmakers, and apartments. Compressed air powers sewing machines. It winds clocks. It runs small motors. No electricity, no gas, no open flame anywhere in the system. That network stayed in continuous operation for more than a century, until 1994. In Germany, the next chapter of this story starts in the 1960s, when engineers at two major utility companies start planning something that had genuinely never existed before, a way to store power for the electrical grid itself, at massive scale, without a single battery. In 1978, there's that year again, the plant goes live. It's still running today, decades later, with a generating capacity of nearly 300 megawatts. Electricity spins compressors. Compressors force air down into underground salt caverns more than 2,000 feet below the surface. When the grid needs power back, that air comes rushing back up, spins turbines, and generates electricity. That facility has now been operating for over 45 years without a single battery cell, and without a single measurable drop in capacity. And then it just went quiet, not banned, not disproven, just quietly, deliberately not talked about anymore. Natural gas got cheap. Coal got cheap. Electricity got cheap enough that storing it stopped making economic sense for a while. And that's exactly the crack in the door your villain slipped through. A technology that nobody can sell you a subscription for, nobody can meter, and nobody can lock behind a service contract is a technology that no industry on Earth is ever going to spend a single dollar promoting. It doesn't get outlawed. It gets buried under a shrug, and the shelf space goes to something with better margins instead. Nobody sat in a boardroom and conspired to erase this on purpose. I want to be straight with you about that. That's not what happened, and it's genuinely not how this stuff works in the real world. Nobody needed to hide it. They just needed you to stop asking. And for 30 years, that's exactly what happened. Then energy prices spiked hard in recent years, and suddenly everyone was staring at their power bill wondering if there was another way. And the whole time, this principle, the one proven back in 1857, had just been sitting there waiting. And here's where the actual numbers get genuinely interesting. The concept itself is almost embarrassingly simple. Your solar panels generate power during the day. That power drives a small compressor. The compressor forces ordinary air into your pressure tank. The higher the pressure inside, the more energy is sitting stored in that tank. In the evening, you open a valve. The compressed air flows out in a controlled stream through what's called a vane-type air motor. That motor spins a small generator. The generator hands you back electricity. No chemical reaction anywhere in this process. No degradation. Nowhere on the storage medium itself. The air that comes out is just air again. The tank is just a tank again, fully ready for the next cycle, with zero memory of how many times it's already done this. Now, let's be completely honest about the numbers, because oversized promises help nobody. A single 80-liter propane tank running at 15 to 20 bar of pressure stores somewhere around 40 to 60 watt-hours of usable energy. That is not a replacement for a 10 kilowatt-hour lithium battery. It was never trying to be. What it actually is a storage system that, after 100,000 charge cycles, holds exactly the same capacity it held on day one. No lithium battery on the market can say that. Independent research out of leading technical universities and applied research institutes puts the efficiency of small compressed air systems at roughly 40 to 55% without any heat recovery. Add a simple thermal capture step, and I'll show you exactly how to build that in a minute, and that number climbs to 55 to 65%. Link 5 of these tanks together in one system, and you've got enough stored power to run LED lighting through an entire evening in a garden shed or off-grid cabin, charge your phone, and run a small water pump. For an off-grid setup like that, this is exactly the right scale. A storage system that never ages, that costs nothing but ordinary air, and that you can build yourself in a single weekend. If you've made it this far, you're not the type who scrolls past and forgets. You're the type who actually builds things. Now, you might be sitting there thinking, the efficiency is way lower than lithium, and you'd be right to think that. A good battery system hits somewhere around 85 to 95% round-trip efficiency. Compressed air sits at 40 to 65%. That's a real gap, and I'm not going to pretend otherwise. But the cost per stored kilowatt-hour, calculated across the entire lifespan of the system, tells a very different story. Research from applied energy institutes has shown that compressed air storage costs can fall below lithium storage costs after roughly 15 years of use, simply because the tank never ages and you never have to replace it. Now picture the full comparison. The industry sells you a $10,000 storage system that's operating at half capacity after 15 years. Standing right next to it is a system you built for under $200, out of parts any scrapyard and any hardware store already carries. It stores less energy per cycle, but it never stops working, and it will not cost you a single additional dollar for the next 20 years. This is usually the exact moment in a video like this where someone tries to sell you a course, a downloadable guide, or an affiliate link to a battery you don't need. I'm doing the flat-out opposite of that. Here's the complete build, free. Right now, no strings, no upsell. You'll need one or more decommissioned propane tanks, the standard 33 kilogram, 80-liter size. Make sure the pressure certification stamp is still legible and that the tank shows no visible corrosion damage. Before you use it, the tank must be completely emptied, purged, and blown out thoroughly with compressed air. This is not optional. Any leftover propane residue inside a compressed air system is a genuine safety hazard, full stop. Expect to pay somewhere between $50 and $80 per tank. Next, a compressor rated for at least 15 bar of output pressure. A basic 12-volt unit works fine, or a small oil-free workshop compressor with a standard outlet works just as well if you're not running this fully off-grid. Expect to spend $50 to $90 on this. Then a vane-type compressed air motor, rated somewhere between 0.3 and 1 kilowatt, paired with a small DC generator or alternator. Pneumatic equipment suppliers carry these combinations for $75 to $160. Round it out with air hoses, a pressure regulator, a pressure gauge, a check valve, and standard fittings. All available at any hardware store for roughly $30 to $55 total. For assembly, place your tanks upright or on their side in a protected, shaded location, a shed, a basement, a covered outdoor area. Keep them out of direct sunlight because heat raises internal pressure. Connect the tanks using standard compressed air fittings. Wire the compressor to your solar controller or directly to the panel. The air motor sits at the output, positioned right after the pressure regulator. Here's something that genuinely matters, and I want to be straightforward about it rather than skip past it the way most videos do. Pressure vessel regulations exist for a reason, and they apply based on the product of pressure and volume, not just pressure alone. A single 80-liter tank at 12 bar sits close to, but just under, the threshold that would trigger additional certification requirements in most jurisdictions. Stay conservative on pressure. Always check your local regulations before putting a system like this into operation. A 5-minute phone call to your local authority costs nothing and protects you completely. Don't skip that step to save time. It's not worth it. Here's a detail I deliberately held back until now, because it only matters once you've actually decided to build this. Air heats up when it's compressed. That heat is stored energy that normally just gets wasted into the air around the tank. Capture it instead. A simple copper coil heat exchanger sitting inside an insulated bucket of about 5 gallons of water will absorb that compression heat. Route the air back through that warm water right before it expands through the motor, and your overall efficiency climbs by 10 to 15%. That's the actual difference between a 40% system and a 55% system. That one detail is what turns this from a fun experiment into a genuinely usable power source. Picture the finished version of this. Your garden shed, one evening in August. Warm light glowing from LED bulbs inside, fed entirely by 5 steel tanks sitting behind the shed. Your phone is charging on a small outlet by the workbench. The pump on your raised garden bed is running quietly. Your next power bill has no line item for that space at all because it isn't even connected to the grid, and it doesn't need to be. And you know with total certainty that this system will perform exactly the same way 10 years from now, because air does not age. The compressors from that German facility that first switched on back in 1978, remember that year, are still standing there today. The old compressed air pipes running under Paris are still sitting in the ground, more than a century later. And somewhere in the Alps, a mountain tunnel still stands as proof that an engineer, over 150 years ago, figured out how to turn ordinary air into real, usable work. This knowledge never actually disappeared. It just stopped being repeated out loud because nobody with a marketing budget got paid to keep telling the story. So here's your villain, in plain sight one more time. Not a person, not a shadowy company, just a system where the only stuff that gets advertised is the stuff somebody can keep billing you for. No conspiracy required. Just a 15-year replacement cycle, a nice fat margin, and 30 years of silence on anything that doesn't fit that model. And maybe that's exactly why it costs you nothing to use it today. The best tools are always the ones nobody profits from, which, funny enough, is exactly why nobody ever showed them to you. If this is the kind of story you want more of, subscribe to Forgotten Ways. The next one's already coming, and I don't think you're going to want to miss it. And if you've got questions about pressure ratings, tank sourcing, or the heat recovery setup, drop them in the comments below. I read every single one, and I'll answer the best ones in the next video.